What is encryption? Encryption is a fundamental concept in cybersecurity that involves converting data into a coded format, making it inaccessible to the unauthorized users. It plays a critical role in ensuring the confidentiality and integrity of data both in storage, data at rest, and during transmission, data in motion. What is encryption? Definition: encryption is the process of converting plain text, which is readable data, into ciphertext, unreadable data, using an algorithm and an encryption key. Purpose: the primary goal is to protect sensitive information from unauthorized access, ensuring that even if data is intercepted, it cannot be understood or used. How does encryption work? Encryption algorithm. This is a set of mathematical instructions used to transform the data. Common algorithms include AES, which means Advanced Encryption Standard, and RSA, which is Rivas Shamir Adliman, and DAS, which is Data Encryption Standard. Encryption key: a secret key or set of keys used by the algorithm to encrypt and decrypt data. So, it is a secret key or set of keys used by the algorithm to encrypt or decrypt the data. The security of encryption largely depends on the secrecy and complexity of the key. So, encryption process: data is encrypted using an algorithm and a key, converting into ciphertext, which is unreadable data. Decryption: the ciphertext is converted back into plain text using the same algorithm and key, then it will be readable. So, types of encryption: symmetric encryption, which is uses a single symmetric encryption. We are understanding types of encryption. The first one is symmetric encryption. So, now we will understand what is symmetric encryption. It uses a single key for both encryption and decryption. Example: AES, and its pros are it's faster and more efficient for large amount of data. Its cons: key management can be challenging since both the sender and receiver must securely share the key. Asymmetric encryption: it uses a pair of keys, a public key for encryption and a private key for decryption. Example: RSA. Pros are more secure for key exchange because the private key never needs to be shared. Cons: slower and requires more computational power. Applications of encryption: data protection, encrypting files, databases, and other stored data to protect against unauthorized access, and communication security, ensuring the confidentiality of data transmitted over networks such as emails, messages, and video calls. Authentication: verifying the identity of user through encrypted passwords and digital certificates. Digital signatures: ensuring the authenticity and integrity of digital documents and software. And what are the encryption in use? SSL TLs, secure socket layer, transport layer security encrypts data transmitted over the internet, securing websites, which is HTTPS. VPN, virtual private networks, use encryption to secure data transmitted between a user and the VPN server. Email encryption, tools like PGP, Pretty Good Privacy, and SMIME secure multipurpose internet mail extensions. Encrypt emails to protect content from being read by unintended recipients. Full disk encryption, encrypting the entire contents of a disk or drive, ensuring that even if the physical device is stolen, the data remains protected. Now we will understand encryption standards and regulations. GDPR, the General Data Protection Regulation, requires encryption for protecting personal data in the European Union. HIPAA, which is the Health Insurance Portability and Accountability Act, mandates encryption of health information in the healthcare industry in the USA. PCI DSS, the Payment Card Industry Data Security Standard, requires encryption of credit card data to protect against fraud and theft. And now we will understand challenges and limitations. The first challenge will be key management. Securely storing, distributing, and managing encryption keys is critical and can be complex. Performance impact: encryption can introduce latency and require additional processing power, especially with asymmetric encryption. Vulnerabilities: weak encryption algorithms or poorly implemented encryption can be vulnerable to attacks such as brute force, side channel attacks, and computing threats. Emerging trends in encryption. The current trend is quantum encryption. With the rise of quantum computing, traditional encryption methods may become vulnerable, leading to the development of quantum resistant encryption algorithms. Homomorphic encryption allows computation of encrypted data without decrypting it, preserving privacy while performing data analysis. Zero knowledge proofs: cryptographic methods that allow one party to prove another that a statement is true without revealing any information beyond the validity of the statement, which is very good. So the best practices for encryption: use strong encryption algorithms, prefer AES 256 for symmetric encryption and RSA 2048 or ECC elliptic curve cryptography for asymmetric encryption. Regularly update encryption protocols. Ensure that you are using up-to-date and secure encryption method. The another best practice of encryption is implement robust key management. Use secure key storage solutions like hardware security models, HSMS, and ensure keys are regularly rotated and backed up. Encrypt data both at rest and in transit. Always encrypt sensitive data, whether it's being stored or transmitted over a network. Follow compliance requirements. Ensure your encryption practices meets industry standards and regulations. Now we will check the summary. So the summary is of encryption is: as cybersecurity threats evolve, so will the encryption methods. We will likely see advancements in post-quantum cryptography, enhancing encryption to withstand quantum computing threats, and increasing adoption of advanced encryption methods like homomorphic encryption for privacy-preserving computations. Encryption is a cornerstone of cybersecurity, protecting data from unauthorized access and ensuring privacy and security in the digital world. Understanding and implementing strong encryption practices is essential for anyone in the cybersecurity field. Now we will check who are the best sellers of encryption currently. The first one will be Symantec. Broadcom, which is also known as Broadcom, offers encryption for data at rest, email encryption, and endpoint security solutions, popular for its endpoint encryption and drive encryption products. McAfee, of course, provides encryption for data on devices, emails, and cloud storage. Known for McAfee complete data protection and file and removable media protection. Microsoft, third one is Microsoft, offers built-in encryption tools like BitLocker for disk encryption and Azure Key Vault for managing encryption keys in the cloud. Widely used for both consumer and enterprise encryption. The fourth one is IBM, provides encryption solutions for enterprise data protection and cloud security. Popular products include IBM Gordium for encryption and IBM Cloud Data Encryption Services. The fifth one is Trend Micro, sixth is WinMagic, and one more by name Sophos. Thank you.